Assalamualaikum warahmatullahi wabarakatuh. Today we are from Group 4 will present our object recognition using Convolutional Neural Network CNN with MATLAB. Before that, I will introduce my group members. First, my name is Siti Aisyah binti Idris.
My name is Wan Darwisha binti Cik Wan Mamakhir.
My name is Nur Izzati Inshira binti Zaharuddin.
And I'm Nur Shahira binti Izan.
These are the content of our presentation. We will explain the dataset before moving on to training and testing phase, and finally a conclusion.
Nowadays, most parents struggle to implement learning with their kids at home because of their busy schedules and other issues. Hence, the objective of this application is to help parents who are trying to teach their kids to recognize different types of stationery. In addition, this application can help deaf people to identify and classify stationeries. With this application, it can analyze and classify the images of stationery into different classes such as pencil, ruler, eraser, and sharpener. For the input data, we will use a total of 400 pictures from 4 different types of stationery. The source of these pictures are from Google Image. Next is output class. We will have 4 different types of stationery, which are pencil, sharpener, ruler, and eraser. The last one is segregation of data, where data will be divided into 100 images of stationery for each class. From these 100 images, we will use only 75 images for training, and the remaining one will be used for validation.
We have conducted 10 experiments with different parameters values. In the first experiment, we used network architecture that included an input layer, 3 convolution plus ReLU layers, 2 max pooling layer, and a classification layer. We used a maximum epoch of 4 and a learning rate of 0.01 in the training options. In experiment 2, we changed the number of sizes in each layer of the convolution plus ReLU from 3 to 6. We also increased the maximum epoch to 6. In experiment 3, the network architecture is reduced to consisting of an input layer, 2 convolution plus ReLU layer, 2 pooling, and a classification layer. We changed the number of sizes in convolution plus ReLU layer from 6 to 5 each. In experiment 4, we only changed the learning rate from 0.01 to 0.03. In experiment 5, the network architecture was modified to include an input layer, 4 convolution plus ReLU layer, 3 pooling, and a classification layer. Odd numbers like 3 times 3, 5 times 5, and 9 times 9 are used to gradually increase the number of sizes in each convolution layer. This was done so that the network could first gather small, local information before gathering larger, more representative data. Stride 4 is implemented in each max pooling layer. The learning rate is decreased from 0.03 to 0.001 and the maximum epoch is raised to 12. In experiment 6, we reuse the parameter values in experiment 2 with modification of raising the learning rate to 0.01 and the maximum epoch is 15. In experiment 7, we use the same network architecture as experiment 5. The size of the convolution plus ReLU layer is 1, increasing to 2 for the following layer. The maximum epoch in training options is reduced to 5. In experiment 8, the parameter values and learning rate remain the same while the maximum epoch increased to 10. This was done to avoid underfitting when training the dataset. In experiment 9, we only increased the maximum epoch to 28. In the last experiment, convolution plus ReLU layer size was modified to gradually increase in odd numbers. This was done so that the network could use the small filter to gather tiny pieces of information and the large filter to gather all the prominent information. The learning rate is reduced to 0.004. A lower learning rate can produce more accurate result. The maximum epoch is increased to 31. Experiment 10 produced 92% of validation accuracy, which became our best experiment. Based on the experiments, we can conclude that higher number of convolution layers, size features and max epoch, lower window size and stride of pooling, higher number of each type of layer, and lower initial rate can produce higher validation accuracy.
Next, final network architecture. For the testing phase, we choose experiment 10 for our final network architecture as it has the highest accuracy among the other experiments, which is 92%. To get this highest accuracy, we decided to increase the maximum epoch to 31 and also reduce the initial rate from 0.01 to 0.004 as it can produce more accurate results. So this is our final network figure. For the input, we have the image of a stationary, and for the feature learning, we have 4 convolution plus ReLU with 3 pooling layers. And for the classification, we have flattened, fully connected, and softmax. Next, we also increase the filter size and the number of filters for the convolutional layer. For example, from 18 2 times 2 convolution plus ReLU to 38 3 times 3 convolution plus ReLU. For the testing phase consists of 4 categories of stationery, which is the first one is eraser, pencil, ruler, and also sharpener. All the images in this folder has been resized, and we will go with the first folder, which is eraser. As you can see, there are consist of 100 images in this folder to be tested for CNN, and the second folder is pencil. Also have 100 images in this category, and the source of images are from Google. And next one is ruler, also consists of 100 images, and there are a few shapes in this category: triangle, rectangle, and also hemisphere. And lastly, the category of sharpener, as you can see, also consists of 100 images that has been resized. And that's all for the data set of stationery. And I will pass to Aisha for the next CNN.
So this is our network architecture. We use experiment 10 for our training. So in here, all the folder will be in the same size, which is 100 by 100. So for our training, we use 75 images for training and 25% for validation. Next, Darisha.
Now we'll define the network architecture of our CNN. The image input layer is 100 times 100 times 1 pixels. Now the feature learning for the first layer is a 10 1 times 1 convolution plus ReLU. The second layer is max pooling layer with pool size and stride 2 times 2. The third layer is a 38 3 times 3 convolution plus ReLU. The fourth layer is max pooling layer with pool size and stride 2 times 2. The fifth layer is a 55 times 5 convolution plus ReLU. The sixth layer is max pooling layer with pool size and stride 2 times 2. And the seventh layer is a 66 9 times 9 convolution plus ReLU. In classification, there are 4 fully connected layers and a softmax layer. In training options, the initial rate is 0.004, the max epoch is 31, and the validation frequency is 30.
Okay, next we'll be proceeding to the testing phase. Our testing phase consists of 2 sections. The first section will be processing our new image that has not been yet in our dataset. Then we will resize our image to 100 by 100 pixels so that we can simulate the properties with our dataset. And then in the line 66, we can see that we'll be converting our image from RGB to grayscale. Run. This is our testing image for the pencil class. So now we'll test the network in the next section. Our network classify our data with pencil with the probability of 99.9%. As you can see in the top 4 prediction graph, pencil has the highest ranking. Okay. Next, I will be proceeding with other classes, which is eraser. Okay. This is our testing image for eraser. Okay. Next, we will test the eraser. Okay, our network classify our testing image of eraser with the probability of 92.6%. As you can see, our image has been resized to 100 by 100 and in a grayscale image. Okay, and in the top 4 prediction graph, eraser has the highest ranking with the probability of 92.6% and sharpener are in the second ranking. Okay, next is Aisyah.
Okay, I will continue. Our third image object will be ruler. So when we run, so this is the image for our ruler. So let's see if our network can classify our image as ruler. So yes, our network classified the image as ruler with 93.7%. So as you can see in the top 4 predictions, it classified ruler as the top ranking, followed with the pencil, sharpener and eraser. So next we will try to test our last input, which is sharpener. So run. So this is the images for our sharpener. So as you can see, our network classified this image as sharpener with 99.6%. So according to our graph predictions, it classifies sharpener as the top ranking, followed with the eraser as in the top 2 ranking.
In summary, we were able to reach the highest validation of accuracy in data training at 92% using this convolutional neural network, and it results our network correctly identify our testing datasets classes. And with this, we can conclude that our network was successful in achieving the goals to help the deaf individuals to correctly identify and recognize stationery. That's all from us. Thank you, Miss.